All right, buckle up. Number 10, the turbulence crisis. It surrounds you every second of every day. You see it swirling when you stir milk into your morning tea. You feel it slam your seat when a commercial jet hits a rough patch miles above the ground. You watch it dance in the gray smoke coiling off a fire on a winter evening. It is called fluid turbulence. It is probably the single most encountered physical phenomenon in human existence. And yet, buried beneath its surface is a shameful, unsettling secret that has haunted physicists for generations. We have zero mathematical proof that we actually understand it. Classical physics depends on a framework called the Navier-Stokes equations, derived nearly 200 years ago. These formulas are supposed to tell us exactly how fluids behave in motion. Aerospace engineers rely on them to build jet turbines. Car designers use them to sculpt aerodynamic bodies. Medical researchers use them to model how blood moves through arteries. But here's the deeply uncomfortable truth. From a purely mathematical standpoint, we cannot confirm whether these equations always hold up. We have no idea whether they always produce smooth, stable, continuous solutions, or whether in specific conditions the math simply implodes and starts spitting out impossible infinities. The Clay Mathematics Institute considers this hole in human knowledge so severe that they have placed a $1 million bounty on whoever can prove or disprove the existence of smooth solutions to these equations. Sit with that for a moment. We can guide a nuclear-powered robot the size of a car to a precise landing crater on a planet tens of millions of miles away. We can detect gravitational ripples from two colliding black holes on the far edge of the cosmos, but we cannot give you a mathematical guarantee of what water does when it flows through a pipe in your kitchen wall. Turbulence is a wild, unconquered force in a discipline that prides itself on order. It laughs at our confidence, reminding us that even the most ordinary corners of physical reality are wrapped in unsolved mathematical darkness. Number 9, the gravity gap. Pick up a cheap refrigerator magnet. Hold it above a heavy iron nail sitting flat on the table. Watch the nails snap upward and lock against it. It looks like a simple party trick. It's actually one of the most disturbing paradoxes in all of physics, one that, by every right, should not be possible. Consider what just happened in that fraction of a second. Every single atom composing the entire planet Earth, a mass of nearly 6 septillion kilograms, was pulling downward on that nail through gravitational force, and yet your flimsy little magnetized souvenir yanked it upward and won, effortlessly, without contest. Why is gravity so spectacularly, almost offensively weak? When placed next to electromagnetism, gravity is weaker by a factor of 10 to the power of 36. That's a 1 followed by 36 zeros. It's a gap so grotesque it shatters the mathematical elegance that physicists believe should govern the fundamental forces. The strong nuclear force, the weak nuclear force, and electromagnetism all share proportional strengths that fit together in a coherent way. Gravity is the frail, baffling outlier that refuses to belong. If gravity were fractionally stronger, every star in the cosmos would burn through its fuel and die within years rather than billions of years. If it were slightly weaker, no galaxy could ever assemble itself. Some theorists have offered a solution so unsettling it rewires the brain. What if gravity is not actually weak? String theory proposes that while every other fundamental force is locked within our familiar 3 dimensions of space, gravity might be leaking, bleeding outward into concealed microscopic extra dimensions folded invisibly all around us. What we experience as a feeble gravitational tug might simply be the diluted ghost of a vastly more powerful force operating in a dimension we cannot see, cannot enter, and cannot begin to perceive.
Number 8. The impossible marriage. All of modern physics stands on 2 colossal pillars. On one side stands Albert Einstein's general theory of relativity, the physics of the inconceivably large. It describes with breathtaking precision how stars arc through space, how galaxies spiral, how massive objects warp the very fabric of space-time around them. It is structured, it is deterministic, it is beautiful. On the other side stands quantum mechanics, the physics of the inconceivably small. It governs the jittery, probabilistic, deeply strange behavior of subatomic particles, quarks, electrons, photons, and the forces that bind them. Here lies the catastrophe. Both of these theories have been confirmed correct by thousands of independent experiments. They are the two most rigorously tested and successful intellectual achievements in the entire history of science. And they are fundamentally, violently incompatible. Attempt to merge the mathematics of general relativity with the mathematics of quantum mechanics, and the equations instantly self-destruct. They generate infinities. They output pure nonsense. Under ordinary conditions, this incompatibility is manageable. You apply relativity to stars and black holes. You apply quantum mechanics to atoms and particles. But there are places in this universe where the unimaginably massive and the unimaginably small collide at the exact same point. Inside the crushing singularity at the center of a black hole. In the very first microsecond after the Big Bang. In these extreme places, reality itself demands a single, unified set of rules, a theory of quantum gravity that works at all scales simultaneously. We do not have one. Every attempt to construct it has collapsed into failure. This means our deepest understanding of the universe has a fracture running directly through its foundation. At the very core of existence, nature is operating according to a single truth that we have not yet discovered. A hidden equation that bridges the cosmic and the microscopic, locked away behind a wall of mathematical contradictions we have not yet found the key to open. Number 7. The strong CP problem. To truly grasp this nightmare, you need to peer inside the nucleus of an atom. Deep inside, where the strong nuclear force chains protons and neutrons together with almost incomprehensible power. Within the framework of particle physics lives a concept called CP symmetry. The idea is this: if you swap a particle with its antimatter counterpart and simultaneously mirror its position in space, the laws of physics should produce an identical result. Nature should not have a preference. The weak nuclear force, the one responsible for radioactive decay, violates this symmetry routinely. It clearly picks a side. But the strong nuclear force? It obeys CP symmetry with a level of precision so exact it borders on supernatural. Here is the problem. The mathematical theory that describes the strong force, quantum chromodynamics, actually permits a large-scale violation of CP symmetry. The equations predict the neutron should carry a measurable electric imbalance, a tiny asymmetry in its internal charge distribution. Decades of extraordinarily sensitive experiments have turned up absolutely nothing. The neutron is balanced to an accuracy of 1 part in 10 billion trillion. Why? The standard model contains a tunable parameter, call it theta, whose value could theoretically land anywhere across a full 360 degrees of possibility. But for some reason that no one can explain, the universe has locked this dial to exactly, precisely, impossibly 0. This level of fine-tuning makes physicists profoundly uneasy. To escape this problem, scientists theorized the existence of a new particle called the axion, a cosmic cleanup crew that would naturally sweep this imbalance towards 0. Despite years of searching with extraordinarily sensitive underground detectors scanning for faint interactions with magnetic fields, the axion has never been detected. The strong nuclear force remains immaculately symmetrical. And we have no coherent explanation for why it refuses to break the rules every other force feels free to bend. Number 6. The missing magnetic ghost. Take any bar magnet. It has a north end and a south end. Saw it cleanly in half. You do not produce an isolated north pole and an isolated south pole. You get 2 smaller, fully complete magnets, each with its own north and south. Repeat this down to the level of individual atoms. The result never changes. Magnetic poles, without a single documented exception, always come in bonded pairs. According to grand unified theories of physics, this should not be the universal rule. In the blistering, incomprehensible heat of the universe's earliest moments after the Big Bang, physics demands that isolated magnetic monopoles should have been created. lone north poles and lone south poles wandering independently through the void. The mathematics of our universe insist they must exist. Paul Dirac, one of quantum mechanics' founding architects, demonstrated mathematically that the mere existence of a single magnetic monopole anywhere in the universe would elegantly explain why all electric charge comes in fixed, discrete units. The theoretical case is airtight. And yet, after more than a century of searching, scanning the depths of space, analyzing lunar rock samples returned by Apollo missions, smashing subatomic particles together at velocities approaching the speed of light, not one magnetic monopole has ever been definitively confirmed. They are the phantom missing persons of particle physics. To explain their absence, cosmologists developed the theory of cosmic inflation, an almost unimaginably rapid expansion of the early universe that would have stretched space-time so violently it diluted any monopoles to 1 per observable universe density. But that is a mathematical patch, not an answer. The equations of physics still insist they exist. Silent, solitary, invisible magnetic charges drifting alone through the darkness of deep space, perpetually escaping detection.
Number 5. The weightless phantom. Right now, as you are reading these words, trillions of invisible particles are passing directly through your body. They originate in the nuclear furnace at the core of the sun. They blast across the vacuum of space, punch straight through the roof above your head, travel through your skull, your brain, your chest, down through the floor, through the bedrock beneath, and exit out the other side of the Earth without disturbing a single atom along the way. They are called neutrinos. For decades, the standard model of particle physics, our most successful and precise map of reality, declared an absolute rule about these phantoms. They must carry exactly 0 mass. They were classified as massless fragments of pure energy, propagating at the absolute speed limit of the universe. In 1998, that rule was broken. Scientists operating a massive underground detector filled with ultra-pure water deep beneath Japan observed something that the standard model declared impossible. Neutrinos come in 3 distinct varieties: electron, muon, and tau. As they travel from the sun to Earth, they cyclically transform from one variety into another. They oscillate. They shapeshift mid-flight. Here is why that is catastrophic. Quantum mechanics states that for a particle to change state, time must pass for that particle. Relativity states that for time to pass for a particle, it cannot be traveling at the speed of light. And if it cannot travel at the speed of light, it must possess mass. The scientists who uncovered this won the Nobel Prize, but the discovery shattered the standard model. We now know neutrinos have mass, yet it is so vanishingly tiny we cannot measure it directly. The Higgs boson, which grants mass to all other known particles, cannot account for neutrino mass through conventional mechanisms. The math simply breaks. Neutrinos are pointing at an entirely hidden layer of physics operating right beneath the surface of everything we know, silently rewriting our understanding of what matter fundamentally is. Number 4. The lithium deficit. Wind back the clock 13.8 billion years to the first 3 minutes after the Big Bang. The universe was a violently expanding superheated cloud of protons and neutrons. In that brief explosive window, the first atomic nuclei were forged in a process called Big Bang nucleosynthesis. Using our most advanced understanding of nuclear physics, scientists can calculate with precision exactly how much hydrogen, helium, and lithium-7 should have been cooked in that primordial furnace. When we observe the oldest surviving stars in our galaxy, the ancient relics closest to the universe's birth, we can check those calculations against reality. Hydrogen, the measurements match the predictions flawlessly. Helium, again, a perfect agreement. Then we look at lithium-7. According to every model we have, the early universe should have forged a specific quantity of it. When we measure those ancient stellar atmospheres, we consistently find only about 1/3 of the predicted amount. 2/3 of the early universe's original lithium is simply gone. This is not a small rounding error. This is a cosmological accounting disaster.
Have we made a fundamental mistake in our nuclear physics models for the Big Bang? Is there an undetected particle, perhaps a dark matter candidate, that interacted with lithium in the early universe and destroyed it? Or is there some unknown process occurring inside ancient stars over billions of years that depletes their lithium reserves? The lithium problem is a glaring, embarrassing crack in our origin story. It suggests that our mathematical model of the universe's birth is either incomplete or, worse, fundamentally wrong in ways we have not yet identified. The oldest stars in the cosmos know something about the dawn of time that they are not willing to reveal. Number 3. The immortal proton. Everything ends. Mountain ranges crumble into plains over geological time. Stars exhaust their fuel and collapse into remnants. Even black holes, the most extreme objects in the universe, will eventually dissolve into thermal radiation over timescales that dwarf the current age of the cosmos. But what about the most basic structural unit of matter? What about the proton itself? Protons are the stable backbone of reality. They constitute the nuclei of atoms. They make up the screen in front of you, the oxygen cycling through your lungs, and the proteins folding inside your cells. According to the standard model of particle physics, protons are perfectly, eternally stable. They do not decay. They last forever. Physicists find this deeply offensive. In the search for a grand unified theory, a single equation capable of describing all particle interactions under one mathematical roof, virtually every serious theoretical model predicts that the proton must eventually disintegrate. It must break down into lighter particles such as positrons and pions. If proton decay is real, it means matter itself carries an expiration date. It means that unimaginably far in the future, long after the final star has gone dark, the dead atoms scattered across the cold, lightless universe will gradually dissolve into a thin mist of radiation. The cosmos will literally evaporate. To catch this happening, scientists constructed Super Kamiokande, an enormous underground chamber in Japan holding 50,000 tons of water so pure it is toxic, surrounded by thousands of light sensors so sensitive they can detect a single photon. Researchers have been monitoring an astronomical number of protons in complete underground darkness for decades, waiting for just one to die. They have witnessed nothing. Not one proton has decayed. This places the proton's half-life at a minimum of 10 to the 34th power years, a number so immense it renders the current age of the universe an irrelevant blink. Are protons genuinely immortal, defying every grand unified model we have constructed? Or are we simply living in a universe that has not yet waited long enough for the slow rot to begin? Number 2. The measurement curse. This is where physics stops being physics and starts being psychological horror. It's called the quantum measurement problem, and it strikes at the most fundamental question imaginable. What is reality, actually? In the quantum realm, particles such as electrons do not occupy a fixed, defined position in space. They exist as a smeared wave of mathematical probabilities, technically present everywhere and nowhere simultaneously until something forces a definite outcome. This is not a philosophical abstraction. It is proven by direct experiment. Fire a stream of electrons at a barrier containing two narrow slits. They behave exactly like waves. Each electron passes through both slits simultaneously, interfering with itself and producing a characteristic alternating pattern on the detector screen beyond. Now install a measuring device at the slits to track which path each electron actually takes. The instant you do this, the instant you introduce an observer, everything changes. The interference pattern vanishes. The electrons immediately begin behaving like ordinary solid particles, passing through one slit or the other, never both. The act of measurement itself has restructured the behavior of matter. How does a mindless subatomic particle detect that it is being observed? Does conscious awareness interact directly with physical reality at the quantum level? Or, as the many worlds interpretation suggests, does the universe continuously branch out into infinite parallel versions of itself every time a quantum event is resolved?
with each possible outcome playing out in its own separate, inaccessible branch of existence. Erwin Schrödinger invented his famous thought experiment, a cat sealed in a box, simultaneously alive and dead until the box is opened, to mock what he considered a ridiculous implication of quantum theory. The joke became the literal state of physics. We have no equation that explains the mechanics of wave function collapse. The implication is staggering. Objective reality may not exist in any definite form until it is observed. The universe may be nothing more than an ocean of mathematical potential, crystallizing into tangible physical form only because conscious observers are here, looking at it.
Now move on.
The unreasonable perfection. And here we are, the final terror, the fine-tuning problem. Strip the universe down to its mathematical skeleton, and you find approximately 26 numbers called fundamental constants. These are the control dials of physical reality: the mass of an electron, the strength of gravity, the speed of light in a vacuum, the energy density of empty space. These numbers have no theoretical derivation. There is no equation that tells us they must be what they are. They are simply brute, inexplicable facts about the universe we inhabit. But if you nudge any one of these dials by even a microscopic fraction in either direction, the universe becomes instantaneously and permanently uninhabitable or ceases to exist at all. If the strong nuclear force were 2% more powerful, protons would fuse before atomic nuclei could form. No atoms, no chemistry, no matter. If gravity were marginally weaker, gas clouds could never contract under their own weight to ignite stars. No stars, no elements heavier than hydrogen, no planets. If the cosmological constant, the energy density of empty space, were larger by even 1 part in 10 to the 120th power, the universe would have expanded so catastrophically fast after the Big Bang that no structure of any kind could ever have assembled.
The precision required for our universe to support complexity is equivalent to firing a dart from the surface of Earth and striking a bullseye the size of a single atom on the far edge of the observable universe. It is a perfection so extreme it defies coincidence. Why is the universe tuned to such absurd precision for our existence? Is it a statistical accident? And if so, does that imply an infinite multiverse in which every conceivable combination of constants plays out and we simply find ourselves in the one rare pocket where the numbers happen to permit life? Or does this degree of calibration suggest something more unsettling, that the parameters governing our reality were deliberately set by an intelligence, whether biological, computational, or beyond our categories entirely? There is no scientific answer. There may never be. We exist on the razor-thin edge of mathematical improbability, staring outward into the dark, with no certain explanation for how the numbers were set, or who or what did the setting.